Hey guys, so in this video I'm going to go over how to graph a parabola using its vertex form. So just a refresher, that vertex form is your a times x minus h squared plus k, and the h comma k values tell you where your vertex is. Okay, so this video is going to be a little bit long. I'm going to go over two different problems because completing the square with these two types of problems is a really different process. So this first one is going to be completing the square, which puts you into vertex form when your a value is just equal to 1. Okay, so let's refresh the first couple of steps here. When you are putting an equation into vertex form, essentially what you're doing is completing the square. You're going through this very special process that takes all these area tiles and things like this and puts them into an exact square shape. So that's really the point of doing this. Now, to start this process, you take your constant term, that plus c, whatever it is at the end, and just move it to the other side to start. So I'm going to begin by adding 3 to the other side. And guys, that step happens every time you complete the square, no matter what kind of a value you have or anything like that. So just move it to the other side. And then we have an x squared plus 4x left over here. So remember, like I said, completing the square is a matter of taking area tiles that represent your polynomial and arranging them in a way that makes it a perfectly square area. So this one x squared tile is the same as this big x squared here, and then I have 4 x's, which are the same as 4 of these green tiles here. Okay, so when you're completing the square, the point is to arrange these tiles in a way that creates square area. So if I have 4 green tiles, then I need to split them up evenly on either side. So I have 2 x's going here and 2 x's going along here. So notice how you only have a square when each side is the same length. So right now, the length of this side is an x plus 2, and the length of this side is also x plus 2. So I know that I've created a square because the dimensions are the same on both sides. But my square is not complete. There are missing tiles, right? So how many tiles do I need to add in order to complete my square? Well, I can see there are 4 missing, and so I could just fill them in with 4 nice little tiles like that. Okay, now I want to point out a really glaring detail right now. These 4 tiles were not here to begin with. Okay, the only thing I actually had here to begin with was an x squared tile and 4 x's. So when I introduced these 4 pink squares, they kind of came out of the blue. So if I add them over here, I also need to add them here. That's kind of why I left these little blank spaces for myself, was to give myself room to add in these missing tiles. Okay, so now this whole filled in area, which is perfectly square, has dimensions x plus 2 by x plus 2. Okay, so essentially, I'm going to maybe continue down here. My y plus 7, so if I add the 4 and the 3, I get y plus 7. And now instead of representing this area as a sum of all the boxes, right, adding all these together, instead of representing area as a sum, I'm going to switch into product mode, which is a matter of taking the factor along this side and multiplying by the factor on this side. So it's x plus 2 times x plus 2, or more simply, x plus 2 squared. Okay, last step, we're super close. We got to put this into vertex form by moving the 7 along to the other side. So now it would be appropriate to move your constant term back over. So I have x plus 2 squared minus 7 because I have to subtract it over this way. All right, now it's, let's see if we can figure out what our vertex is. When reporting your vertex, the x value here is always going to switch signs. So essentially you're looking for a value of x that would cause this factor to kind of equal a 0. That's one of the ways that I think about it. So the h value is not 2, it's actually negative 2. So the h value inside of this factor is going to switch signs. So from positive 2, it becomes negative 2. So there should be a negative 2 here. The k value doesn't do that. There is never any switching with the k value. So if you see a -7, that is your k value, just -7, like that. Okay, so the other thing that is really common you'll be asked to find as well when you're graphing with vertex form is to at least find your x-intercepts too. So I guess before we do that, let's just plot this point. So out here at -2 and then down to 7. So down here, right about there. So that would be my vertex point here. And now let's see if we can also find our x-intercepts. So if I want to find x-intercepts, that's a matter of solving for when y is equal to 0. And you can do this a number of ways, but I'm going to show you how to take your vertex form and solve for 0 using vertex form. Okay, so I'm going to plug in 0 for y, actually. Sorry, I'll keep using black. And I have x plus 2 squared minus 7. Okay, now in order to solve this equation, remember to use your skill of like taking the square root of things. Now, before I can take a square root and get rid of this power here, I've got to move the 7 to the other side, right? Remember how we have to isolate the thing being squared. So whatever it is being squared, you have to isolate it first. So I move the 7 over, add it to the other side. My x plus 2 squared is now by itself. So I can square root. So I have square root of 7 plus or minus. So anytime you take a square root of a number, you have a positive and a negative solution. And that's just equal to x plus 2, since the square root and the square cancel each other out. And my final answer, I need to subtract the 2 to the other side. So my x values are -2 plus or minus the square root of 7. Okay, clearly not a very nice answer, but it's essentially, you know, what you'd expect. You're at -2, and you move out square root of 7 amount, which I think is less than 3, but bigger than 2. So somewhere kind of out here. And then -2, and you move that direction as well. So not like super precise right now. You can grab a calculator and get more precise. But that's essentially what your problem looks like. Okay, so the next problem I'm going to go over is going to be completing the square where your a value does not equal 1. All right, so here's the next problem that I want to go over with you guys. It looks something like 3x squared plus 6x minus 5. And you can see right away that our a value is 3 and not 1. So completing the square is a bit of a different process. All right, the comforting thing is that you're still creating square area, and you're still going to take the first step the same. Like every single time, no matter what equation you're given, you move your constant term to the other side. So let's start by adding 5 over here. Y plus 5 equals 3x squared plus 6x. Okay, so the extra little stuff that you need to do is like when you're creating square area, we're only allowed to use x squared tiles. 1 x squared tile, not 3. Because if I'm looking at this right now, 3x squared technically means I have 3 of these big yellow squares, and I'm not actually allowed to do that when I'm completing the square because there's no way to arrange it in a nice square area shape. So instead what we do is we do this extra little trick or step where we factor the 3 out of the sum. So I start by noticing like, oh, 3x squared and 6x both share a factor of 3. And even if they didn't, we would just force it, right, and have a fraction or something. But for now, the numbers work nicely. So I'm going to factor out a common term from the sum. And I'm going to take the whole a value, which is 3. You have to do that every single time. So I picked a nice example where 3 would go into this term and this term. If that isn't always the case, though, you're going to have to work with a fraction, and like, that's okay, we can do this. All right, but here's how it looks for now. So essentially, I want you to like let the whole rest of the world just drop away. All you're looking at is x squared plus 2x. So I have 1x squared term here and 2x's going on here. So I'm just focusing on this part of my equation because I want to complete the square using those terms. So if I arrange this in a square area kind of a way, I can see that the dimensions are x plus 1 and x plus 1, so it's a square. And I only need to add one tile here to make it a complete square, so it's filled in area. All right, so that essentially means that for this portion of my equation, in order to take these area tiles and make a square, I have to add one tile. But what does that mean in terms of the context of the whole equation? Because remember that I have a 3 sitting outside here. If I distributed that 3 through, like let's take a look at what that would become. 3 times an x squared would be 3x squared. 3 times the 2 gives me 6x. And 3 times that 1, well, check it out, class. It's actually being added like 3. So when you're looking at balancing your equation, yes, I only added one tile here to make a square area. But in terms of the context of the whole problem, 3 times 1 is the value 3. And so what I've actually added to both sides is 3. So over here, I need to add 3 in order to keep everything balanced on both sides of the equation. Okay, so now I can start to simplify. On this side, I have y plus 5 plus 3. So that just becomes y plus 8 equals. Now I'm going to kind of tunnel us back, like tunnel vision, back to my sum. X squared plus 2x plus 1. That would be the area if I added all the boxes together. But I don't want to do that. I'm going to write it as a product of x plus 1 times x plus 1. So I'm going to rewrite it as x plus 1 squared, just like that. So notice how I took this whole area right here and compressed it into a product, which is just x plus 1 squared. And now to put this thing into vertex form, I need to add the 8 to the other, subtract the 8 to the other side. So this is going to look like 3 times x plus 1 squared minus 8. And now that is vertex form of this equation. So my vertex is going to look something like, remember that the h value kind of switches sign. So if you see x plus 1, that means your h is technically negative 1. And the k value is still negative 8. So let's take a step over here and graph that really quick. It's going to be negative 1. And then down at here, 8. So there's my vertex going on right here. And then I'll demonstrate how to find your x-intercepts as well. I'm going to move my vertex so I have a little more room. Oops. How about negative 1, comma negative 8? All right. So if I'm looking for x-intercepts, remember that that is when y is equal to 0. And so I can take vertex form right here and set this thing equal to 0. All right, in order to solve, you don't want to square this thing out. You just want to try and isolate whatever's being squared and then take a square root. So that's the technique you're using here. I want to begin by adding 8 to the other side. And then this thing is not by itself yet. I still have the 3 in front, so I need to divide that away. So those are gone. So I now have 8/3 is equal to x plus 1 squared. I know, it's just beautiful. Square root of both sides. Yeah, it's getting even nicer. Okay, so I have something like my x plus 1 is going to be equal to plus or minus square root of 8/3. And then to finish solving and isolating, I need to subtract that one to the other side. Don't panic, it's just math. Right? 8/3. Okay, so there is my beautiful set of x-intercepts. It's essentially saying, start at that -1, and then you can subtract square root of 8/3 this way, or add square root of 8/3 that way. If I had a calculator, I could kind of estimate exactly what that looks like. Since I don't, I'm just going to estimate it really poorly and put it, I don't know, somewhere like here and somewhere like there. Okay, so there's my super ugly parabola, but essentially, that's the process you're taking, is looking at completing the square and using one technique or the other based on you know, your A value, like do you have to factor it out first or not? So be really mindful of what you're doing, and then you can find your vertex and solve for x-intercepts from